Hello students, welcome back to the video classes. Today we are going to solve few more examples from the exercise 1.1. In last class we have seen the types of relations, that is reflexive relation, symmetric relation and transitive relation. In this class we are going to solve few more examples like question number 5. Relation R in the set A of human beings in a town at a particular time given by. A is a set of human beings in a town at a particular time. R is a relation defined as R is equal to, it is a set containing the order pairs x, y such that x and y work at the same place. This is the relation given to you in a set builder form. Now to determine whether this R is reflexive, symmetric and transitive. Given is A be the set of human beings. You have to check the reflexivity. For all x belongs to A, as x comma x also belongs to R. Since A is an infinite set, therefore we should mention here x and x both work at the same place. Therefore R is reflexive. Now when the set is an infinite set, it is very difficult to draw the relation in the roster form. That's why we have to give this type of explanation. Symmetric relation. To define the symmetricity, we need two human beings. For all x, y belongs to given set A, if the order pair x, y belongs to R, implies y, x belongs to R. That is, x and y work at the same place, then y and x also work at the same place. Therefore, R is symmetric relation. Dear students, here there is a minor mistake. This is called a symmetric relation. R is symmetric relation. Symmetric relation. By mistake we wrote here it is not symmetric, it is a symmetric relation. Now you have to check the transitivity. To define the transitive relation, we need three human beings. X, y, z belongs to A. If x, y belongs to R, y, z is also belongs to R, then x, z belongs to R. That is, x and y work at the same place. Implies y and z also work at the same place. Then x and z also work at the same place. Therefore, R is transitive relation. Therefore, the given relation R is reflexive, symmetric and transitive relation. This is one of the example to define the equivalence relation. The relation is an equivalence relation if it is reflexive, symmetric and transitive. This was the question given in the examination in the year 2015 for 3 marks. Once again, the relation R defined on the set A. It is a set containing x, y such that x is a wife of y. The relation between x and y is a given. X is a wife of y, means y is the husband of x. Let me define the solution. Let A be the set of human beings. Now to define the reflexive relation, we need a one human being. For all x belongs to A, x comma x is not belongs to R, because x cannot be a wife of itself. That is, x cannot be a wife of x. Therefore, R is not reflexive. Symmetric relation. For all x comma y belongs to A, if x comma y belongs to R, then y comma x is not belongs to R, because here x is a wife of y implies y is not a wife of x, or y cannot be a wife of x, because if x is a wife of y, y is a husband of x. Therefore, y never be a wife of x. Therefore, here R is not a symmetric relation. Transitive relation. For all x comma y comma z belongs to A, if x is a wife of R, if x is a wife of y belongs to R, and y cannot be a wife of z because y is a husband of x. Therefore, y cannot be a wife of z. Therefore, it is not belongs to R. Therefore, obviously, x cannot be a wife of z, which is not belongs to R. That is, x is a wife of y and y is not a wife of z. Then x is never be a wife of z. Therefore, R is not a transitive relation. Therefore, this relation is neither reflexive, symmetric nor transitive relation. We will go through the one more example. R is a relation defined on the set A. It is given by x comma y belongs to, that is x comma y, such that x is the father of y. Here the relation between x and y is a father relation given to you. Let A be the set of human being. Now let me check the reflexivity, symmetricity and transitivity. To define the reflexive relation, we need a one human being belongs to the given set A. Here, for all x belongs to A, dear student, this is an element A it is, because we are saying that x belongs to A. This is not belongs to R, it is x belongs to A. As x comma x is not belongs to R, because x cannot be a father of itself, or x cannot be a father of x. Therefore, R is not a reflexive relation. To define the symmetricity, we need two human beings. For all x comma y belongs to A, if x comma y belongs to R, that implies y comma x is not belongs to R. Now, x is a father of y. Therefore, y cannot be a father of x. Hence, R is not a symmetric relation. Transitive relation. To define the transitivity, we need three human beings. X comma y comma z belongs to A. If x comma y belongs to R, y comma z belongs to R, then x comma z is not belongs to R. That is, x is the father of y, which is belongs to R. Y is a father of z, that is also belongs to R. Then x cannot be a father of z. X is a father of y and y is a father of z. Then x cannot be a father of z. X will be a grandfather of z. It is. That's why here x cannot be a father of z. Therefore, R is not a transitive relation. Now, this relation is neither reflexive, symmetric nor transitive. Therefore, this is one of the important example to give. The relation is neither reflexive, symmetric nor transitive. We have such many more examples in the exercise 1.1. Dear students, I suggest you to solve those examples so that you may perfect to define the reflexivity, transitivity relations. Now, in this video, I have done one question for an equivalence relation. That is the first question, the relation which is reflexive, symmetric and transitive. And the remaining two examples are to define. It is neither nor a equivalence relation, not a equivalence relation. I hope you have understood the today's class. If you have any queries, please contact the given below number. Thank you. Stay home, stay safe.